The prospect of mining the moon is just around the corner. So what are they so excited about? Should we be doing it at all? How would it even work? Let's explore the unexplored. The moon is just a cold, empty rock with nothing of interest but a 50-year-old American flag stuck in the ground, right?
When we arrived there, almost a little bit more than 50 years ago, it's interesting to hear the recordings from the second man on the moon. When he stepped out of the lunar lander and looked around, he said, "This is magnificent desolation." But our view of the moon has changed radically since then, from magnificent desolation to a place that is full of important resources that we may use once we land there. Just to give you an idea of some of those, 45% of the moon is oxygen. It's just that it's tied to the rocks. These are oxidized rocks, but that can be heated and you can extract plenty of oxygen. It's got 21% of silicon for anything that we do with semiconductors, iron and titanium, very important elements, aluminum and calcium and magnesium and things like this, potassium and phosphorus. And also you find radioactive materials like uranium and thorium. Then there is the possibility of finding water. Water exists there, and that can be a total game changer, because water not only is good for humans, but mostly for propellant. Because water, you can split it into hydrogen and oxygen, and it can serve as the most energetic propellant that we know.
This is incredibly exciting and really does demonstrate how there are more than enough resources to maintain a permanent base. We've got metals to develop technology and oxygen for breathing. We could use moon rock to 3D print habitats and extract hydrogen to fuel deeper space exploration, which could be a big game changer. But there are actually a couple of really exciting resources that in the future could make sense to bring back to Earth. The first is energy from light. Scientists are trying to look at how we can create solar factories on the moon. Now, the problem comes with how we transport that energy back to Earth, and one way is using microwaves. We could beam them through the atmosphere, through the clouds, and collect them in a receiver here on Earth, which could give us enough power to supply the entire world 24/7. This is still a long way off and doesn't make financial sense yet. But there is an element on the moon that we don't have much of here on Earth, one that could radically shake up the energy industry.
One of those elements is called helium-3. Helium-3 has been identified as a potential fuel for what's called fusion energy. Right now, the way that we obtain nuclear energy on Earth is by fission. You hit an atom, you split it, and in the process, you generate energy. Fusion is totally different. Here, you bring two elements, two particles, and you fuse them. And in the process of doing that, which requires a lot of energy, then a lot of energy is also released, and is released directly into electricity. You don't have to go through heating and then steam and then producing electricity. And even better, the residue is helium. Just helium, the one that, again, you can use for inflating balloons. So it's a non-radioactive waste that you can get out of that.
So it seems like mining the moon could not only serve us in space, but also provide helpful resources for us back here on Earth. But that's likely somewhere in the future. What about today? There is one resource that countries are especially interested in, and that's rare earth elements. The interest in rare earth elements has exploded because they are one of the main components of the communications industry. Neodymium is used in speakers, lanthanum in lighting, yttrium for computer screens, and gadolinium in X-rays. Despite being called rare earth, they're not actually that rare. The issue is that they're found in concentrated areas, which makes them a highly valuable bargaining chip for countries that have them within their borders. One of the countries that dominates the rare earth industry is China. Because of this, countries like the US are starting to ask questions like, well, what if China decides to restrict access to the US? Where can we get them from? The answer is, you guessed it, the moon! But would the US just be able to go up and take what they want? What are the laws for governing resources in space? The 1967 Outer Space Treaty states that no single country can claim ownership over any celestial body. But it said little about mining. And because of this ambiguity, two schools of thought have developed as to how we interpret the treaty. And this has got space lawyers, space lawyers, debating the issue.
So far, the international discussion has centered around two major viewpoints. The one argues, since the moon belongs to everyone, it means that the resources in the moon's subsurface, whether it's water or iron or gold or platinum, belongs to everyone as well. And you can't allow a single state to say, okay, I'm going there, or I allow my private sector to go there and mine it for their own commercial profit. That's the one interpretation. The other interpretation says, well, it's a global commons, and just like the high seas, once you are there and you do something there, part of the freedom of the high seas / outer space, you can own it and sell it and make money with it. The comparison is then with the fish in the high seas. So these are the two opposing views. We still have no legal agreement amongst all the states that this is the appropriate interpretation. So we still have a ways to go before all the states are on the same page.
Because of this ambiguity, countries are now taking legal matters into their own hands. In 2015, the United States took the first step by saying that any company that sets up operations in the United States will have the right to access, extract, utilize, and even sell resources from the moon. Not own it, but the right to access and utilize it. The following year, Luxembourg became the first European country to establish a legal framework around space resources. After that, the United Arab Emirates joined in, and most recently in 2020, so did Japan. So you're seeing how these countries are moving independently while trying to abide by the United Nations Treaty, but while finding ways to extract resources. But even if we can mine the moon, should we?
That is a concern. Are we going to mine the moon so much that we're going to start changing the face that we see there? Are we extract so many resources that it may affect its orbit or its physical parameters? Some of those concerns are understandable, but some of them shouldn't be of much concern. But in terms of causing major damage on the moon, I think that's not going to happen, at least in many decades or many centuries. But we should start planning ahead on how to do it so that it doesn't cause a problem in the long run.
So should we mine the moon? Well, if you have any interest in travelling to the moon or beyond, or potentially solving our energy crisis, then the answer may be yes, with the caveat that it's done legally and with no irreparable damage. Over the next few decades, the picture is going to start to get clearer as the moon gets busier and we find out exactly what is there and how much of it there is. When that happens, that's when things are going to get interesting. And hopefully we'll be able to find a way to share resources and avoid conflict here on Earth. Who owns Mars? It's a surprisingly big problem. With the USA and China planning to send humans by the 2030s, and with private company SpaceX potentially sending them by 2026, it's gonna get pretty crowded up there. You can even go online and buy a bit of Mars yourself. I've got mine. So who owns what up there? And what happens if things get nasty? I think we're gonna need a space lawyer. It's time to explore the unexplored. Space law sounds like a fantasy job, but it does kind of make sense. Surely there must be some kind of rules and regulations. Well, yes, and it started in 1957. The US and the Soviets are in the midst of a Cold War. They're sworn ideological enemies. Suddenly, the Soviets launch Sputnik, the first ever human activity in outer space. It flies around the Earth a few times, including directly over the US. And that raised a whole bunch of new questions. If an enemy vehicle enters your airspace, then you can shoot it down. But suddenly people had to think about, where does airspace end and space begin? The prospect of war in space was so frightening, they decided to keep the war on terra firma. To the surprise of the rest of the world, they joined together and drafted the Outer Space Treaty. Finally, it's over to the space lawyer.
The most fundamental baseline principle is found in Articles 1 and 2 combined, which basically makes outer space into a kind of a global commons, an international area, legally very similar to the high seas, and no single state can act as if outer space or part of the outer space or even part of the moon is part of the national territory. It's basically open for all states, and freedom for states to be active there is the bottom line. The drafters of the Outer Space Treaty were basically concerned with two elements, if you will. One was the military use of outer space, and at a secondary, subsidiary level about science. The treaty didn't really discuss things which we are confronted with today as questions, at least theoretically, like the settlement on the moon or human settlements on Mars.
So it's good that states are free to use space, even if they weren't thinking about settlement. But that wasn't the only thing they weren't thinking about in 1957. The treaty only refers to political states. It doesn't even mention private companies. So does that mean that the billionaires of the world are exempt from the treaty?
One of the clear drawbacks looking back at the Outer Space Treaty was the absence of any detailed reference to the private sector. So what you see in the Outer Space Treaty is only one almost fleeting reference to the private sector in the guise of what they call non-governmental entities. But at the same time, it made sure that the state, in this case the United States or any other state, where those activities belonged to, was the one being responsible. And then Article 7 followed that up with also liability. So not only you as the United States will be responsible for them, for whatever they do, and you will be liable for any damage they cause by doing that. So the United States cannot dodge any international responsibility just because SpaceX or Virgin Galactic or Blue Origin does something in outer space.
Okay, so I get that ultimately states are responsible for what private entities do in space, how they operate, and any damages. But what about the use of land on Mars? We're planning on building habitats and living on Mars. Is that even allowed?
So we have to make a very fundamental and important distinction between, on the one hand, the prohibition for any state to own part of Mars. On the other hand, the freedom of outer space activity, which is the other part of the global commons thing, also means the freedom of simply establishing a habitat, putting space objects there, which then serve as houses, or probably even excavate minerals locally and build a habitat from those minerals. That all is in principle, again, allowed. And of course, there is a tension between those two, because it is one thing to be allowed to land somewhere, to put people down somewhere, maybe to have them live there for 25 or 30 years. But at what point in time should we say, wait a minute, now we are moving to something which looks too much like a real colony, which is prohibited by the Outer Space Treaty? But again, that question has not been solved yet.
But it's not like here on Earth, where if you break a treaty, we can physically take action. Mars is over 300 million kilometers away. So if the USA or Russia or China or a private company starts breaking the rules up there, wouldn't it be pretty hard to stop them?
Next question is then, of course, what happens if a private entity disregards the international rules of space law? Well, if that happens, then of course the first line is that the operator who goes beyond the terms of the license will be held criminally liable under the laws of his own country. It becomes a little bit more complicated at the second level when we go to the international arena. Either these states have to agree to a tribunal, or they have to sort things out on a diplomatic level. And of course, then the reality of the international community kicks in, that the bigger you are as a state, the more you might get away with.
These are all crazy scenarios that could arise in the future. And talking of the future, many people see Mars as a future second home for humanity. But how would our laws on Earth work in space? And if no country is allowed to claim sovereignty over celestial bodies, then how will it be governed if there are communities and multiple generations of Martian people?
But of course, at some point in time, certainly when they start living there, knowing that they will never return to Earth, when they probably get babies there who have never been on Earth for any part of their life, there will be a tendency for those quote unquote colonies, I prefer to use the word settlements actually, to say, well, we don't want to be ruled by this earthbound state anymore because they have no idea what it means to live on Mars and to be safe on Mars. So we want to create our own legal regime, and sooner or later that may actually become, we want to create our own state. I often compare this with the Pilgrim Fathers who went to North America and then after a number of years said, well, why are we still paying taxes to the British king in faraway London? So it took a war of independence before the United Kingdom finally accepted, okay, let them be on themselves, let them be their own state. I just hope that when that happens in space, we are more peaceful as terrestrial states in allowing those to go out on their own. But that's still decades away, if not much further.
If my first chat with a space lawyer has taught me anything, it is that there is still a lot of grey area in space law. If we want humans to play nice on Mars, then we're going to have to answer a lot of these unresolved questions. And if you're silly enough to have fallen for one of those bogus websites that claims that you can buy a piece of land on Mars, well,
the paper is just worth the paper it's written on, and it doesn't give you any title. Don't expect to reap any benefits from it.
So humans are going to Mars, and soon, lots of them. SpaceX could be going as soon as 2026, NASA and China by the 2030s, and India, Russia and the United Arab Emirates are all planning on it too. But what happens when they all get there? How can we actually survive? Well, some lucky scientists have already been there. Okay, not really. They're living in a Mars simulation right here on Earth to troubleshoot what could go catastrophically wrong when they do go to Mars. It's time to explore the unexplored. Okay, let's break this down into two key challenges we're going to need to overcome if we go to Mars: the physical and the psychological. Let's start with the physical. In many ways, Mars and Earth are quite alike. It has a similar dry landmass, volcanoes, craters, and its days are just 37 minutes longer than ours. What would you do with an extra 37 minutes? But that is where the similarities end, and it's the differences where the problems start. Gravity is just 38% of that on Earth. It means that you can jump higher, but you'll lose muscle mass. Imagine Dwayne "The Rock" Johnson training his chest every day with an 100-kilo bench press to maintain that impeccable physique. Suddenly, you land on Mars, and all that's available is a 38-kilo weight. Over time, his chest is going to get weaker and weaker. And it's a similar situation for astronauts going to Mars. Then there's the atmosphere, which is incredibly toxic. It's around 95% carbon dioxide. And to make matters worse, Mars is bombarded with radiation. And you get the idea. Mars is extremely dangerous. But luckily, there's a team of scientists who are actively trying to resolve these problems before we get there.
So when we talk about Mars simulations, what we're doing is we are trying to mimic the surface phase of a human robotic Mars mission. There's a million things that can go wrong. So when we think about Mars, we're talking about a world that is up to 380 million kilometers away from the Earth, which happens to be about 1,000 times the distance to the moon. And so it's probably 1,000 times more things that can go wrong. What we learned through our missions, it's not only the big things that are challenging, it's the small things. Think of being in the spacesuit. Despite the air condition, you start to sweat, but you cannot scratch your nose in the helmet, obviously. So little things like a little piece of foam where I can simply rub your nose into it and make sure you don't sneeze inside the helmet, which is a very bad idea, by the way, is a little thing that doesn't sound very glorious, but it's the things that make your work easier. And really making sure that you have gone through the ins and outs of those little details can be a game changer. We have been doing those Mars simulations for 13 campaigns now, since almost 20 years now. And there's literally hundreds of experiments we did, and many of them went wrong or did not turn out the way like we expected them to do. And so we live and breathe the mantra of fail fast, fail cheap, and have a steep learning curve, because that's where you get better. We died many deaths. Simulated, of course.
So gravity, atmosphere, and radiation are not actually the main concerns. These are the big things that we already know about, that we can create technology to help mitigate them. It's the small things that we don't know about yet. They're what could kill you, and there's a lot of them. So far, the answer to most of the physical challenges has been better technology and better spacesuits. But physical survival is only part of the battle. The team are also pioneering incredibly advanced psychological studies to figure out who will be the best humans to go to Mars.
We think that there's no such thing as a born astronaut. When we select analog astronauts for the Austrian Space Forum, this has been done very, very carefully. It's a multi-month process. We're evaluating, we just did a recent count from the last class, 637 individual parameters, anything from your cholesterol level to the length of your pinky finger and your ability to entertain little children and psychological factors and so on. You're much more looking for team players who are outstanding when it comes to health, but they also have technical competence, but at the same time who are also to display social warmth. They know how to tell a joke in the airlock at the right time. They know how to cook. They know how to do a magic trick. They can play the guitar. They can also settle down a broken leg or so. We are not looking into psychological clones of each other, but they need to complement each other. And so we're looking, actually from the anthropometric point of view, we're looking for the average Joe, the average Jane.
Or an average Josie?
So we have people who, in the beginning, who have a high technical competence, but then the work doesn't stop here, because you need to continuously monitoring the activities throughout the mission. That's exactly what we're doing with our simulations. For instance, we are in a previous experiment in 2018 in Oman, we had an artificial intelligence machine learning algorithm actually, who was looking into the pitch of the voices when people talk to each other. And we know when people are under stress, the average pitch shifts just slightly above the average. Or for this mission in Israel right now, we had one of the experiments, was a fantastic experiment. The astronauts would have locators, so we could produce heat maps where the astronauts would congregate throughout the mission, or also relative heat maps, how much physical spacing they have in between them. If you don't like somebody, you tend to increase the distance, for instance. And so we're looking at the methods that tell us, here's a stressful situation emerging before the people would realize it. And magically, then everything goes according to plan. And so it's about keeping them functional, by keeping them happy, by feeding them well, no food, no fight. But also making sure they don't smash each other's heads before leaving the lunar orbit.
So, with the right training, technological development, and people management, Dr. Gromer believes that we can definitely survive on Mars. But so far, we've only been focusing on a finite scientific mission. Go, survive for a bit, and then return. And that's understandable, given how many risks there are for even doing that. But this hasn't stopped people from dreaming even bigger. Elon Musk has famously said that we're going to Mars for good, to become a multi-planetary species. Some scientists have taken this and come up with some scary, speculative solutions to explain how we might survive. One of those is through mutations. The high levels of radiation on Mars could cause our bodies to change, and it's possible that some of these changes might actually help us survive. It's hard to predict how quickly this might take and the effects that it might have, but some scientists say that it could take just a few generations. Like, we could see changes in our skin tone to deal with the radiation. Could we go green? Our bone density might alter to account for the lack of gravity, and we might not even need our immune systems because we'll be living in such a sterile environment. But all of this is only relevant if we're actually going. Will we really ever be setting off to Mars for good?
Yes, we will. I can give you this in written. It's only a natural process. I think at the core of our beliefs and of our heart and our DNA, we are a migratory species. Our children and grandchildren will look up to the sky, to the moon, and see little dots of light out there on the lunar surface saying, we are out there. It's a statement to the universe. And the same will happen to Mars and the worlds beyond. It's just a matter of time.
Ever wonder what would actually happen if an alien civilization made contact? If they haven't already. Would the public be made aware, or would it be kept secret? How would we decode what they're saying? And how on earth will we reply? Well, believe it or not, there is an entire field of science that is dedicated to this.
By sending intentional messages, we'll let the civilizations know that we want to make contact.
There actually is a protocol that tells us what to do in case we pick up a signal that looks promising.
It's time to explore the unexplored. Seth Shostak is a senior astronomer at SETI, the rather cunningly named Search for Extraterrestrial Intelligence Institute. For decades, the institute has been leading the way in actively searching for extraterrestrial signals, in the hopes of making the first contact with ET.
Most people, when they think of looking for intelligent life, they have some scenario kind of like in Star Trek, right? You get to a fancy rocket and you just, rocket off to some other world and look for it. We simply can't do that. But what you can do is maybe find the aliens at home by eavesdropping on their radio waves, or maybe they have flashing lasers.
If alien civilizations are anything like us, then they'll emit plenty of signals all the time. Radio, television, microwaves. All we need to do is just eavesdrop on one of these signals, and then boom, we've got contact. To make this possible, SETI uses 42 radio telescopes called the Allen Telescope Array. They direct these telescopes towards clusters of stars that we know have exoplanets, in the hopes that one of those exoplanets is broadcasting signals.
Now, we're looking for signals that are what are called electromagnetic signals, which is to say, flashing lights or radio waves. I mean, radio is just another form of light, if you will. So that's what we're doing. And why do we do that? Well, we know that it would work. We know that signals like those could go, from one star system to another and not become so weak that you could never detect them. I mean, it's always possible that they've developed some new physics that allows them to communicate in a way quite different from what we're envisioning. But, you can't do an experiment based on science you don't yet know. So we go with what we do know.
They haven't found anything definitive yet, but what happens when we do?
A lot of people do think that there's some sort of official procedure if you find a signal. I mean, wouldn't the Pentagon get involved and so forth? Well, they've never shown much interest in getting involved in it. And asking for a procedure is like asking Chris Columbus, hey, Chris, look, you're going to get these 3 ships and head west on the Atlantic. What if you discover a new continent? Have you got a protocol for that? Well, he didn't, and it wouldn't have helped anyhow.
Are you as surprised as me to hear that there is no official protocol for when we receive alien signals?
Now, people who are involved with SETI tend to think ahead. There actually is a protocol that tells us what to do in case we pick up a signal that looks promising. It's very trivial. It just says, check out this signal, tell everybody, and don't start broadcasting back until you have the consent, if you will, of the rest of the world's population. So you don't have one society trying to monopolize communication with the aliens. What would happen after that is you would get everybody in the world who can study this thing because they got a big antenna or whatever. Then they would build new equipment that might be able to get the message. In other words, the bits that presumably are attached to that transmission. And once you have those, now you have, the equivalent of the hieroglyphics, and now you try and figure out what they might mean.
Bear in mind, these might not be intentional messages. We could be picking up their equivalent radio and TV transmissions that have just stumbled into our radio telescope. But for now, let's assume that they are sending a direct message. What happens next?
What if we decide to talk back? How will we encode that? Will we send them stuff in colloquial American English, a language they always seem to understand in the movies, or what else? Probably it's better just to send lots and lots of information. I would just send them the internet myself.
Really? It's mostly video games, TikTok dances, and ASMR.
Replying to any signal that we might pick up is, actually, it's very controversial. You wouldn't think so, but it is. What are you going to say? And there's some people say you shouldn't reply at all. So, the matter of replying is controversial because of this potential for some sort of danger. On the other hand, I'm sure that if we were to pick up a signal next week or next month or next year, There are going to be plenty of people who have the ability to construct a transmitter in a backyard dish who are going to be sending their own messages to the aliens.
That's more terrifying than sending the entire internet. But what's odd is if aliens exist and there isn't some mass government conspiracy, then why haven't we heard anything? Well, as SETI continues their search for extraterrestrial intelligence, there's another organisation that thinks that we shouldn't be waiting to hear from them, we should be actively sending signals to potential alien habitats. What would you call an organisation that messages extraterrestrial intelligence?
My name's Doug Vakoch. I'm president of METI International. For over 60 years, SETI scientists have been searching for signals from other civilizations. So far, we haven't found anything. But what happens if every civilization is doing exactly the same as us? It would be a very quiet universe. That's why we should be sending messages of our own to try to elicit first contact. I'm at a scientific facility far north of the Arctic Circle called IceCat, an organization that sends radar signals into the sky to understand the composition of our upper atmosphere. But the interesting part, the new angle, is that we can also use it to send signals to nearby stars. One of our prime targets is the nearest star to Earth, Proxima Centauri, which is orbited by a planet in the habitable zone. We're sending signals that communicate some core ideas of science like chemistry, the periodic table of elements, something that we and the aliens have in common. By sending intentional messages, we'll let the civilizations know that we want to make contact. And in some cases, that may just be what's required to get a response.
Whether you think we should just wait and listen or actively send messages out into the expanse of space, the search is well and truly on. We haven't yet found evidence of life outside the Earth, let alone intelligent life, but scientists do believe that there is life out there. And remember, these signals can take a really long time to transmit.
In the best case scenario, we could send a message and get a reply in just 8 years. That's how long it would take to communicate with the nearest star to Earth. More realistically, it could take centuries, even millennia to communicate. So this is an inherently multi-generational project.
So there may well be another planet 1,000 light years away whose messages are hurtling towards us. And it could be any day now that we finally hear from them. Or maybe they're just watching, listening, biding their time. Or if they're anything like us at all, they've been meaning to message us back. And they will. Just after one more scroll. Wormhole scientists are absolutely buzzing. So what's going on? Sci-fi writers have always loved wormholes. They're a convenient way to whiz a character through space at impossible speeds. But for years, scientists didn't really take much interest in them. Luckily, there has been a recent boom in wormhole research. So what's happening? Could we one day travel through a wormhole? And what would happen if we did? Let's explore the unexplored. Let's start with what a wormhole actually is. You've probably got an image like this in your mind, a tunnel or a bridge. And that's exactly what it is. A bridge between two parts of the universe. One way of thinking about a wormhole is almost like two black holes back to back. The black holes warp the fabric of space-time so much that it completely bends back in on itself, and the openings can allow you to pass straight through from one point to another. To understand how these sci-fi-like wormholes might work, we first need to understand the traditional idea of a wormhole. One that's equally as interesting, but perhaps a little less useful for space travel. A non-traversable wormhole. To help explain that is theoretical physicist Juan Maldacena, one of the pioneering experts in wormholes, who's actively researching some very exciting, albeit mind-boggling, science.
So a non-traversable wormhole is a bit like this picture of the tunnel. And so with the exception that it's a tunnel that is present at one moment in time, and then at later times it stretches and becomes thinner. And eventually it collapses completely and it stretches almost infinitely. And so if you try to traverse this tunnel, you would go into the tunnel and the tunnel closes before you can exit on the other side. So that's why it's called non-traversable. And this closing of the tunnel is similar to, well, it's the same actually as the singularity you have in the interior of black holes. And so if you try to go through this tunnel, you would die. So it's not recommendable to, it's not recommended.
Right, so this doesn't seem like the most practical wormhole in the world. There would have been a lot of very short sci-fi films if the leading character just hopped into one and immediately died. On the other hand, you could binge watch all of Doctor Who in about 5 minutes. So how could we make one that we could actually travel through? The previous thinking was that wormholes would immediately collapse because they're so inherently unstable. What was missing was some sort of matter that would prop the wormhole open long enough to travel through. And this is where it gets interesting.
To have a wormhole that can be held open and be traversable, just as a theoretical question of whether it is possible with the matter we know, it is possible, but only when they are very small. Now, you can also ask the question of whether could we discover some other type of matter so that we could have a very big wormhole that we as a person could go through. And the answer to that is yes. So we could have some new form of matter that hasn't been discovered. It's very unlikely that this form of matter should exist. That should put that from the very beginning. But it is theoretically possible to have that kind of matter. And they would have to be, their mouths have to be very big so that they wouldn't kill the traveler. Because if a person goes through a region where the curvature of space is relatively large, you would be pulled, your head is pulled from your toes, and you would die. So you have to make sure that the curvature of space-time is weak enough. And for that, you need that the mouth of the wormhole should be as big as the size of the Earth. So very big, so much bigger than ourselves.
Keeping up? Right, so there's the traditional wormholes, the non-traversable ones that as soon as you enter, they collapse. Bad idea. So what do you do when something collapses? You prop it open with something. Good idea. And what do you prop it open with? Wood, scaffold, a force field? No. A weird type of matter that opposes the force of gravity that stops the wormhole from collapsing. We don't know if it exists, but it theoretically could. It doesn't defy the laws of physics. Simple. Well, there's more.
And then with this type of matter, you could have a wormhole, but it would take a long time to go through it as seen from the outside. So you could have one here and one on the other side of the galaxy, let's say, or some far away. And then you could go through the wormhole. It would take you, let's say, 20,000 years. And that is the time for someone that remains outside. But for the traveler, it could take a very short time, like a second. You would just go through it and you start traveling very, very fast. And because you travel very fast, your clock runs much more slowly. And for you, it looks like it was just 1 second.
So, in theory, we need a new type of matter that we don't know exists yet to have antimatter properties that allow it to prop open a wormhole the size of the Earth. And if we make it through without any particles tearing through us and avoid having our bodies stretched and our heads pulled off, if all of that happens and we make it to the other end, everyone you know would be dead. Great. Look, needless to say, this is all theoretical, but it is based in real physics and it's incredibly exciting. There's a big buzz around wormhole science at the moment, which is usually some sort of side area of research. And this is down to some new breakthrough discoveries. Scientists have finally proven that entering a black hole is not necessarily a one-way trip. While this probably won't help with the issue of travelling through a wormhole, it does stop the laws of quantum mechanics from breaking, which is a big relief to a lot of people.
There's a development that has happened in the last couple of years where people have realized that something similar to wormholes are responsible for getting the information out of black holes. So there was this famous information problem for black holes that you can send information to a black hole and the black hole would emit Hawking radiation that apparently has no information. But it seems that wormholes managed to get this information out of the black hole. So yeah, that's, I think, the most exciting development of the last few years.
So previously, people thought that anything entering a black hole couldn't leave it. This was known as the black hole information paradox. Even though black holes emit radiation, Stephen Hawking suggested that this radiation didn't contain any of the information pertaining to what went into the black hole.
I discovered that black holes are not that black after all. They give off what has been called Hawking radiation. Because of this emission, black holes will lose mass and eventually evaporate completely. The Hawking radiation seemed to be random and featureless, so it appeared that all the information about what fell in the black hole was lost.
However, new studies suggest otherwise, that in fact you can decode information coming out of a black hole and it's not lost forever. So, wormholes could exist, and they're far more weird and complex than movies would allow you to believe. Okay, they're far less practical, but when has practical ever been fun? So, if you're ever hurtling through outer space, headed towards the barrel of a wormhole, and you previously would have thought about going in, you'll be pretty glad you've seen this video.